we now discuss the solution of a problem from the section coordinate geometry, and this given question is based on the concepts of a line and an ellipse. This question has appeared in the joint entrance examination main held on 25th June 2022 in the second shift. The given question is the line y is equal to x plus 1 meets the ellipse x square by 4 plus y square by 2 is equal to 1 at 2 points P and Q. If R is the radius of the circle with PQ as diameter, then 3R whole square is equal to. We are given 4 options. Option A 20, option B 12, option C 11, option D 8. We are given a line y is equal to x plus 1 and an ellipse x square by 4 plus y square by 2 is equal to 1. This line is meeting this ellipse at 2 points P and Q. If R is the radius of the circle with PQ as the diameter, required to find the value of 3R whole square. This is the given question. We now discuss the solution of the problem in detail. We have the ellipse, let us denote it by E, whose equation is x square by 4 plus y square by 2 is equal to 1, and the line denoted by L, whose equation is given by y is equal to x plus 1. It is given that this line L meets the ellipse E at 2 points P and Q. Let us say the coordinates of P and Q respectively as x1, y1 and x2, y2. Because the line L is meeting the ellipse at 2 points, we take y is equal to x plus 1 and substitute in the equation of the ellipse and solve for x and thereby solve for the corresponding y. Now this will imply in the equation of the ellipse put y is equal to x plus 1. That will be x square by 4 plus x plus 1 whole square by 2 is equal to 1. Take the LCM and expand x plus 1 whole square. Then we get this one. Now make a simplification. Then you will get 3x square plus 4x minus 2 is equal to 0. It's a quadratic in x. And the roots are given by x is equal to minus b plus or minus under the square root of b square minus 4ac by 2a. And simplifying, we'll get x is equal to minus 2 plus or minus under the square root of 10 by 3. So we got two roots. Let us say one of them is x1, the other is x2. Let x1 is equal to minus 2 plus under the square root of 10 by 3 and x2 is equal to minus 2 minus under the square root of 10 by 3. The corresponding y1, y2 we will now calculate. Then y1 is equal to x1 plus 1. x1 value substitute here plus 1. Then you will get 1 plus under the square root of 10 by 3. y2 is equal to x2 plus 1. Take the value of x2, substitute here and simplify. You will get 1 minus under the square root of 10 by 3. Thus, we got x1, y1, x2, y2. Then we proceed further in the next slide. That is what we have done so far. So x1 is here, y1 is here, x2, y2. Now it is given R is the radius of the circle with PQ as the diameter. That means PQ as the diameter. Let us compute PQ and equate it to, because it is a diameter, equate it to 2R. So 2R is equal to the length PQ. The length PQ is P is x1, y1, Q is x2, y2. So we know the distance formula under the square root of x2 minus x1 whole square plus y2 minus y1 whole square. We know x2, we know x1, we know y2, we know y1. So we compute now. Is under the square root of x2 minus x1. So this minus 2 cancels and you will get minus 2 under the square root of 10 by 3 whole square. And similarly, y2 minus y1 is minus 2 under the square root of 10 by 3 whole square. There equals. Each is when you square it, each is 40 by 9. 40 by 9 plus 40 by 9, that is 80 by 9 under the square root of. So take this is written as 2 by 3 under the square root of 20, and this is 2r. So 2r is equal to 2 by 3 under the square root of 20. 2 cancels. Cross multiply. You will get 3r is equal to under the square root of 20, and we want 3r whole square. So square it. 3r whole square is equal to 20. So that's what is wanted in the question, and we got it. The answer is 20. Let's look at our options. Our answer 20 appears against option A. Therefore, the answer for this question is option A. That is the detailed discussion of the solution of the problem, which is based on the concepts of line and ellipse from the coordinate geometry. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.